Let's consider all of the quantum numbers for a hydrogen atom. These quantum numbers come naturally from the solution for the equations of motion for the electron and the hydrogen atom. So first we've already seen N. N gives the energy of the hydrogen atom, and the energy, as we've seen before, is the Rydberg constant divided by N squared. The next quantum number that comes in the solution is called the angular momentum quantum number, because it gives us the angular momentum of the electron, and the angular momentum is equal to the square root of L, the quantum number, times L plus 1, all multiplied by h bar. And h bar is equal to h over 2 pi. So h bar appears a lot in quantum mechanics. And L, the quantum number, can range from 0, 1, 2, 3, all the way up to n minus 1. So, if n, quantum number, is equal to 3, then L can have the following values: 0, 1, and 2. 3 minus 1 is 2, so that's the maximum L can have, but it can also have all values less than n minus 1. There is a third quantum number, given the symbol m sub L, and it gives the projection of the angular momentum on the z-axis. So, okay, say we have our Cartesian coordinate system. This would be x, y, and z axes. And say we have an angular momentum vector, L, here. The projection along the z-axis would just be the length that vector has if we do a right angle with the z-axis to the top of the L vector. So the length in the z-axis direction is the angular momentum projection along the z-axis, and it is just the quantum number m sub L times h bar again. M sub L can have the following values. It can range from negative L all the way through 0 to positive L. So those are the values m sub L could have. So say if we had an L value of 2, m sub L could equal negative 2, negative 1, 0, 1, or 2. So it can range from negative L all the way to positive L in integer values, meaning whole numbers. Now if L equals 1, m sub L can have the range of values minus 1, 0, and 1. If L equals 0, m sub L can only be 0. The last quantum number is given the symbol m sub s, and it gives the spin angular momentum of the electron. And so say if you had an electron, it could spin clockwise or counterclockwise on an axis, and since the electron is charged, then you have an acceleration of charge. It produces its own little magnetic field, and the spin angular momentum will tell us the magnitude of the spin, how fast the electron is spinning in a sense, but it only has two values. M sub s can be negative 1/2 or positive 1/2. And the spin angular momentum is equal to oops, 1 times h bar, the absolute value of m sub s under the radical. So those are the four quantum numbers of the hydrogen atom. N, often called the principal quantum number because it gives us the energy. L, the angular momentum quantum number, which gives us the magnitude of the angular momentum of the electron. M sub L is called the magnetic quantum number due to historical reasons through experiments. And M sub S is called the spin quantum number. So in order to describe the hydrogen atom fully, we need all four quantum numbers.